Welcome, geometry students, to class today on this Monday the 13th. Hope you guys are doing well. Hope you're ready to learn some math today, or at least go over some math. Sorry about Friday's fiasco. Not sure what happened. That was a video from last year, and just so you know, I do preview the videos. In fact, if you'll remember, I told you guys to fast forward to the 1 minute and 34-second mark, and that's because I had listened to a little bit of it, made sure it worked, but obviously I'm not going to sit and listen to 30, 45 minutes, hour, whatever, of a video. So I don't think that'll happen very often, and I apologize for it. And so we're going to do Friday's work today. So here are some quick announcements. We will have a quiz on Wednesday. Tomorrow I will go over a little more what's going to be on the quiz. So quiz on Wednesday. You did not owe me any homework from over the weekend, so you have nothing to turn in, and this is due tomorrow. The assignment right now we're going to do together is due tomorrow. Today's date, although I'm not giving you any notes, but if you want to write it down, today's date, oh, that's not right, is it? Let's fix that real quick. There we go. Today's date is the 13th, as I mentioned earlier. All right, I'm going to go ahead and grab my book and turn to page 368. You can do the same thing if you would like to. And I'd like to encourage you to try the homework on your own. You don't have to sit here and watch the video straight through, okay? You can if you want to. But it might be better off to do the whole assignment and then check the odds in the back of the book. And if you miss any, kind of watch the video. And then the evens, you can watch the video and check your evens that way. All of that is up to you, okay? You're seniors, and there's one sophomore, and the rest of you are seniors. I believe Martin is a senior as far as I know, and Haley's a sophomore. But you guys should know by now to be able to figure things out and do what's best for you. So without any further waiting, let's get started. Numbers 1 through 28, page 368. Get your books out, paper, pencil, calculators, and let's get started. Problem number 1 is in your book, and it reads as follows. If two triangles are congruent, must they be similar? And the answer is yes. And let me show you quickly how, okay? Here is a triangle, and then I'm going to quickly do this. There we go. Here's two identical triangles. They're congruent. Now let's say this is a length of 1, this is a length of 4, and this is a length of 6. So 1, 4, 6. And of course, if they're congruent, then that means all of the angles have to be congruent, because whenever two triangles are congruent, you remember this from last semester, whenever two triangles are congruent, then what? CPCTC, corresponding parts of the two congruent triangles are congruent. And so here's two congruent triangles. Y'all see that okay? Now, are they similar also? Yes, they most definitely are. Okay? Watch. Remember how to check for similar triangles? First of all, are all of the angles congruent to each other? Yes. Number 2, 1 over 1, those two sides correspond. 4 over 4. And 6 over 6. Remember what we have to do? We have to make sure all of the sides are proportional. So we list corresponding side over corresponding side, then we reduce each one. 1 over 1 is 1, 4 over 4 is 1, 6 over 6 is 1, and so all of these are equal. The ratio is 1 to 1 to 1. So yes, if two triangles are congruent, they will also be similar. Always, always. But now look at number 2. Number 2 is different, okay? Please watch. Number 2 says, if two triangles are similar, must they be congruent? And of course the answer is no. I mean, I'm not going to spend a lot of time on this, but look, here's a triangle. And then here's a bigger triangle. Let's say this is 2. Let's say this is 4. Let's say this is 3. Let's say this is 6. And this is 5. And this is 10. And then we're going to say that this angle is congruent to this angle to this angle, this angle to this angle, and this angle to this angle. Now, are these two triangles similar? Yes, they are, because are all three angles here congruent to their three corresponding angles over here? Yes. Are all of the sides proportional? Well, you tell me. The 2 increased to a 4, so that's 2 times 2. The 3 increased to a 6, so that's 3 times 2. And the 5 increased to a 10, that's 5 times what? 2. So did we multiply all 3 sides by the same number? Yes, we did. So these two triangles are similar, but are they congruent? Now, come on, guys. It's obvious they're not congruent. There's no way. I mean, congruent triangles have to have congruent angles and congruent sides, and they don't have congruent sides. So no, not every triangle that's similar, they are not going to be congruent necessarily. Not always. No. All right. Let's move on to number 3. And here we go. All right, numbers 3 through 6. We're going to use these triangles right here. And number 3 says, list all pairs of congruent angles. Okay, let's do that very quickly. Obviously, angle A is congruent to angle L. That's pretty obvious. Angle B is congruent to angle M. And angle C is congruent to angle N. Now, how do I know that? Look in the directions, please. In the directions, it said triangle ABC is similar to triangle ALMN. Do you see that in the directions? So I know angle A has to be congruent to angle L. Angle B has to be congruent to angle M. And angle C has to be congruent to angle N. See, a lot of you thought that I knew these congruency statements right here just by looking at the diagram, and you cannot do that. You have to look at your similarity statement. Okay? All right, moving on to number 4. Number 4 says, write the ratios of the corresponding sides in a statement of proportionality. Okay, we practice this. Side AB corresponds with side ML. So I'm going to say BA over ML. And then this side here, BC, corresponds with MN. So I have BC over MN. And then this side here corresponds with this side here. So I have AC over LN. And then set them equal. There. We learned how to do that in class last week. That's called a statement of proportionality. Okay, moving on to number 5. Find the scale factor of triangle LMN, this triangle here, to this triangle here. Now, do you remember how to do that? The first triangle they mentioned was LMN, so that side from this triangle here will go up top. So we pick a side from this triangle. We're going to pick 21. We put 21 up top. And then it says triangle LMN to triangle ABC. ABC is the second triangle mentioned, so we come over here secondly. And what side from this triangle corresponds with 21? Well, 28 does. So 21 over 28 is your what? Scale factor, but you got to reduce it. 7 goes into both of those numbers, and you get 3/4. Now, Mr. Earhart, what if we chose a different side? It wouldn't matter. If you chose 15, you would put 15 right here over 20. And 15 over 20 also reduces to 3/4. Okay, so that's how you find a scale factor. All right, moving on to number 6. Find the value of x. Well, first of all, we can use ratios and proportions to do this. Watch how I do this, please, students. Watch carefully. I know that this side here that I'm trying to solve for, x, corresponds with 27. They're corresponding sides. So I can say x goes over what? 27. And then I can also say that that equals, and then I don't care which other side you pick over here. It's up to you. I'm going to pick this side. And 28 corresponds with 21. So I'm going to say x over 27 equals 28 over 21. Now, I'm looking for my calculator. I know I brought it here somewhere. Here it is. Now, we have to find what x equals. And I taught you last week, whenever two fractions are equal, you can cross multiply. So 27 times 28 would be 756. and that equals, and then you cross multiply again, 21x. Now divide both sides by 21 and you get 36. So 36 equals x. So there we go. We found the length of this side, and it's 36. All right, let me grab a quick drink of water here. And let's move on to number 37, or number 7, excuse me. Are the two rectangles shown similar? Well, let's find out. I've taught you how to do this. Number 1, make sure all of the angles are congruent to their corresponding angles. And that's true. I'm going to put little check marks. This angle is congruent to this angle. This angle is congruent to this angle. This angle is congruent to this angle. And this angle is congruent to this angle. So we're good. Next, we have to check for proportionality. Okay? So 7 goes with 15. So I'm going to put 7 over 15. And then I'm going to put 4 over 10. 4 over 10. And they should be equal, and they're not. You cannot reduce 7/15, and you can reduce 4/10. You get 2/5. Are those two fractions equal? No way, not even slightly. So if these two sides are not equal, then that means the sides are not proportional. Thus, these two rectangles are not, they are not similar. They are not. Okay, moving on to numbers 8 and 9. The directions for 8 and 9 read as follows. List all pairs of congruent angles. So let's quickly do that. Look at your similarity statement here. I'm not going to keep writing this angle symbol over and over. I'm just going to go fast. I'm going to say P is congruent to D, Q is congruent to E, and R is congruent to F. There we go. I just looked up here, matched up P with D, Q with E, etc. And now let's continue on. The directions also state to write the ratios of the corresponding sides in a statement of proportionality. So here we go. Look at your statement here, your similarity statement. See PQ? PQ corresponds with DE. So I'm going to say PQ goes over DE. And then look, QR corresponds with EF. So I'm going to put QR over EF. And then notice that PR corresponds with DF. So I'm going to say PR over DF. And then set them equal. And there you've done it. You've written your statement of proportionality. All right? So we listed out the congruent angles, and we listed out a statement of proportionality. Moving on to number 9. We're going to do the exact same thing. Angle A is congruent to angle Q. Angle B is congruent to angle R. Angle C is congruent to S. D is congruent to T. And E is congruent to U. Now, how do I know that? I just matched them up. A goes with Q. B goes with R, C goes with S, D goes with T, and E goes with U. Okay? Now, the next part, they want us to write a statement of proportionality. So AB corresponds with QR. So AB over QR. And then BC corresponds with RS. So I have BC over RS. And then I have CD over ST. So CD over ST. And then I would have DE corresponding with TU. So then DE goes over TU. And then hold on, don't forget A and E are a side. So AE, side AE, would correspond with side QU. And now set all of those equal, and you have your statement of proportionality. Okay, so here's your congruent angles, and here's your statement of proportionality. All right, let's continue on and take a look now at number 10. A student was asked to list all pairs of congruent angles and write the ratios of the corresponding sides in a statement of proportionality. Copy the diagram and correct the student's mistake. Well, first of all, F should go with J, and that's good. G should go with K. Oh, that's a mistake right here. Here's one. See that? G should go with angle K, because here's G and here's K. And then H, angle H, should go with L. So this should be angle L. So there's two mistakes. Now let's look at the sides down here. Notice they have FG up top. Here's FG. So JK goes with FG, and that looks good. So put a little check mark on this fraction. Here's KL. KL is right here, last two letters. So GH should be in the bottom, and that looks pretty good. And so check mark there. And then FH, which is right here, FH would go with JL, of course, and that is also correct. So check mark there. So this was the only mistake right here. The student made a mistake with listing out their congruent angles. All right, let's take a look at number 11. Now numbers 11 through 16 have the same directions, and the directions state, determine whether the polygons are similar, and if they are, write a similarity statement and find the scale factor of B to A. So let's get after it. Number 1, notice how all of the angles are congruent. Number 2, let's quickly check the sides. Side 20 corresponds with 15, side 24 corresponds with 18, and side 12 corresponds with 9. Let's reduce these. You will get 4/3. Here you will get 4/3, and here you will get 4/3. So all of the angles here were congruent with all of the angles over here. And number 2, the sides are proportional. So yes, we have similar triangles. So next they want us to write a similarity statement. So here we go. It would be triangle GHJ similar to triangle. Now here's G with one mark, so D would come first over here, and then the second letter over here is H. H has 3 marks, so E would come next over here, and then the only letter left we haven't used over here is F. So there we go. There's your similarity statement. Now, it did not matter which order you wrote GHJ. You could have put triangle HGJ, triangle JHG, triangle JGH. It doesn't matter. But whatever order you list these 3 letters here, that's going to influence in what order your letters are over here. Okay? And then next in the directions, they want us to find the scale factor. Now listen, the scale factor of triangle B to triangle A, or figure B to figure A. So if you'll look at the directions, they say the scale factor of figure B to figure A. So we're going to start with figure B and pick a side. It doesn't matter which side. I'll pick this side. It doesn't matter. And I'm going to put 15 over, well, what side corresponds with 15? 20 does. And now we're going to reduce it, and you'll get 3/4. So there's the scale factor. All right, let's take a look at number 12. Notice all of the angles are congruent, so everything's good there. So let's quickly check the sides and see if they're proportional. 6 corresponds with 12, 10 corresponds with 20, and 8 corresponds with 16. Reduce each one, and you get 1/2 equals 1/2 equals 1/2. So yes, these two figures are similar because the angles are congruent and the sides are proportional. So next they want us to write a statement of similarity. So I'm going to say triangle PMN is similar to triangle. Now remember, these 3 letters right here could have been written in any order that you want, okay? And that's fine. Okay, P corresponds with K, so K comes first. Next is M, and M corresponds with L, so L comes next. And then obviously J comes next. So there's your statement of similarity. Now let's write a statement of proportionality. All right? Well, it looks like you can just use this right here. I mean, just use your similar statement. I mean, the first 2 letters are PM. Oh, I'm sorry, that's not what it says. I apologize to you. It says find the scale factor. Sorry about that. Find the scale factor of B to A. So pick any side you want. I'm going to pick 20 and put it up top. And then the side that corresponds with 20 is 10. So I'm going to put a 10. And 20 over 10 reduces to 2. So 2 is the scale factor. All right, number 3. Obviously, these two squares are similar. That's obvious because look, I mean, if this is a 4 and this is a 4, then this is a 4 and this is a 4. If that's a 5 and that's a 5, then that's a 5 and that's a 5. How do I know these two figures are similar? Well, first of all 4 angles here are congruent to all 4 angles over here. That's number 1. Number 2, notice if I write the sides like this, 4 over 5 equals 4 over 5. If I keep doing this, I'm going to get 4/5, 4/5, 4/5, 4/5, and obviously they're all equal. So these two figures are similar. Now, I want us to write a statement of similarity. So I'm going to say square is, sorry for yawning, I apologize, square JKLM, JKLM is similar to, now I could have written these 4 letters in any order, but since I put J first, then E would come first, and then K second, so F would come second over here, L is third, so G would be third, and then lastly H. So there is your similarity statement. Now, next they want us to write the scale factor of figure B to A. So pick any side over here, 5, and match it up with its corresponding side over here, 4. So 5 over 4. And that is the scale factor of figure B to figure A. All right, let me quickly get a drink of water. And we are just about halfway done, number 14. All right, now let's see if these two figures are similar, okay? Now watch. Notice this angle is congruent to this angle to this angle. All of my angles over here are congruent to their corresponding angles over here. Now let's check the sides of proportion. Let's check the sides to see if they're proportional. 8 would go over 6, so 8 over 6. 10 would go over 7, so 10 over 7, and then set them equal. Well, if you reduce both fractions, here you get 4/3. 10/7 you cannot reduce, and there's no way that 4/3 equals 10/7. So because the sides are not proportional, then we simply say these two figures are what? They are not similar. Okay? They are not similar. Okay, continuing on to number 15. All right, notice all of the angles here are congruent to all of the angles over here. So that's good. You always got to check the angles first. Now let's check the sides for proportionality. 6 corresponds with 3, so 6 over 3. 4 corresponds with 4, so 4 over 4. If you reduce 6 over 3, you get 2. If you reduce 4 over 4, you get 1. And obviously 2 does not equal 1. And so these sides here in this figure, figure A, are not proportional to these sides over here. So these two figures are not similar. Number 16, let's be very careful here. Do you see what they're doing to you? They're trying to confuse you by having one triangle face one direction and another triangle face another direction. So please be really careful on number 16. Listen to me and be careful here. Notice this angle is congruent to this angle. That's good. This angle to this angle. That's good. And this angle to this angle. That's good. So all of the angles are congruent in this figure to all of the angles over here. However, number 2 are the sides. Sorry for yawning, I apologize. Are the sides here proportional to these sides over here? Well, let's see. Let's match them up and let's see. XZ. Now, please look at XZ, guys. Watch this. Do you notice how this side right here has 2 marks at the end and 3 marks at the end? Do you see that? Which side over here has 2 marks at the end and 3 marks? This side right here. So this side corresponds with this side here, just so you guys are aware of that, okay? So 6.75 goes over 4.5. Now I'm going to cross them off. I'm done with those two sides. Now notice this side right here, XY, has 1 mark at the end and 2 marks at the end. Which side over here has 1 mark and 2 mark? Well, it's this side here. So this side corresponds with this side. So 12 corresponds with 8. So next I would have 12 over 8. Well, the only two sides left to use would be 9 over 6. So we're going to go ahead and put 9 over 6. Very good. Now we're going to reduce each one and see if we get the same fraction. First of all, 4 goes into both of these numbers, so I would get out 3 halves. 3 goes into both of these numbers, and so I get out 3 halves. Now over here, this is going to be a little different. Please watch what I do. Please, students. I don't want decimals in this fraction, so I'm going to move this decimal 2 places so it's totally gone at the end. So I have 675. But if I move this decimal up top 2 places, I must also move this decimal 2 places, 1, 2. So it ends right here. I've got to put a little 0 in. So now I have 450. So 675 over 450 is the exact same thing as this original fraction right here. So now I'm going to take 675 over 450, and I'm going to take this fraction and I'm going to reduce it. All right. Now, if you do that correctly, you will get, trust me, 3 halves. I would recommend, first of all, maybe reducing this whole thing by 5. And if so, you would get 131 over 90, I believe. And then 45. Did I make a mistake here? Let's see, 45. Let's see. Okay, I'm back. Yes, I made a little mistake here, and I apologize. When you reduce 675 by 5, you get 135, and then 15 goes into both of these numbers. No, 45 goes into both of these numbers. 45 goes into 135 3 times, and 45 goes into 90 twice. So you get 3 halves, 3 halves, 3 halves. So the sides are proportional. So yes, these two triangles are similar. Yes. And so next they want us to write a similarity statement. So I would say triangle X, Y, Z is similar to triangle. Now you put X first, that's 2 marks, so T would come first over here. Your second letter is Y. Y has 1 mark. Over here, R has 1 mark, so R comes next. And the only letter we haven't used over here is S. So there's your statement of similarity, or your similarity statement. Now, let's find the scale factor from figure B to figure A. So we start with figure B because it says in the directions from B to A. So let's pick a side from figure B. We'll use 6. So 6 is right here. And now be careful. What side corresponds with RS? 1 mark and 3. Well, 9 does, the side down here. And so 6 over 9 is your scale factor. Reduce that and you get 2/3. All right, let me grab a quick drink of water and let's continue on. Now, numbers 17 through 20 have the same instructions, and these instructions say, the two polygons are similar. Find the values of X and Y. Now, this isn't too hard. Let me teach you. I'm not sure if we did any examples of this, but it's not too hard. Watch carefully. They already told you these two triangles are similar, okay? So what you want to do is you want to find some sides here that have 2 numbers. Or in other words, you want to find a side with a number that corresponds with the side over here with a number. Let me show you what I mean. Okay, these two triangles are similar. Notice how 18 pairs up with what side? 12. And notice how they're both numbers, okay? There's no X's and no Y's. So I'm going to put 18 over 12 equals, and then 21 corresponds with Y. So 21 over Y equals, X corresponds with 20, so X over 20. Do you see how I did that? I just wrote a proportionality statement. That's all that I did. I just put the corresponding sides over the corresponding sides and set them all equal. Mr. Earhart, how can you be allowed to do that? Because they told you in the directions the two triangles are what? Similar. And if two triangles are similar, what do we know? We know their angles are what? congruent, and we know their sides are what? Proportional. So we know that because their sides are proportional, that we can set up a statement of proportionality. Now, here's how I'm going to solve for x and y. I'm going to put these two together, and that's going to be one problem. So 18 over 12 equals 21 over y. And then I'm going to put these two together because, I mean, if 18 over 12 equals this and this equals this, then 18 over 12 definitely equals x over 20. So I'm going to say 18 over 12 equals x over 20. And now we have two problems we can quickly solve. Let's cross multiply. 12 times 21 would give you, my calculator says 252. And then 18 times y would be 18y. Now divide both sides by 18 and you will get 14. So y equals 14. Now let's continue on over here. Let's go ahead and multiply 18 times 20, and that would give you 360. And then we're going to multiply 12 times x. That will give us 12x. And now divide both sides by 12. And when you divide both sides by 12, you will get 30. So there we go. We found the missing sides on the two different triangles. All right. Number 18. We know these two triangles are similar, and we're going to solve for x and y. So let's go ahead and write out our statement of proportionality. I'm going to start with x. Now be careful. Do you notice that x corresponds with 18? Do you see why? This side right here has three marks at the end and 2 marks at the end, and this side over here has 3 marks and 2 marks. So x corresponds with 18, so I have x over 18, and then 16 right here corresponds with y, so next I would have 16 over y, and then lastly 20 corresponds with 15, so I would have 20 over 15 equals. Okay, so here we go. My one problem could be x over 18 equals 20 over 15. There's one problem. And then for y, I would say 16 over y equals 20 over 15. So let's cross multiply and let's solve these, okay? 18 times 20 would be 360, and 15 times x would be 15x. Now we're going to take 360 and we're going to divide it by 15. If you do that correctly, you will get 24, so 24 equals x. And then over here, we're going to cross multiply. Y times 20 is 20y, and 16 times 15 would be 240. And then we're going to divide both sides by 20, and if you do that correctly, you will get 12. Y equals 12. Okay, there we go. Moving on. Number 19. All right, now notice they already have this written very nicely for us. It's written in the correct order. So I'm just going to very quickly say 6 over 12 equals 11 over 22 equals x over 16 equals 10 over y. Check and make sure that's right. 6 over 12 and 22. Yeah, that is correct. Okay, so because these two figures are similar, notice how I wrote my statement of proportionality. 6 goes with 12, 6 over 12, 11 over 22, etc. And now I can go ahead and, it really doesn't matter, there's more than one way to do this. You could say 6 over 12 equals x over 16. That's one way to find x. Or you could use 11 over 22, this fraction right here. You could say 11 over 22 equals x over 16. Either way, you will get the same answer. And so, let's go ahead and cross multiply. 6 times 16 is 96, and 12 times x is 12x. When you divide both sides by 12, you will get 8 equals x. 8 equals x. And then we can also take 11 over 22 and set it equal to 10 over y. Okay? Now, you could have also used 6 over 12 instead of 11 over 22. It doesn't matter. Let's cross multiply. 11 times y is 11y. 22 times 10 is 220. And divide by 11, and you should get out 20 for y. Okay? Y equals 20. Let me grab a quick drink here. Almost done, guys. Very close to being done. All right, let's take a look now at number 20. They've got it turned the right way for us, so that's good. So I'm very quickly going to say 6 corresponds with 4, 9 corresponds with 6, x corresponds with 8, and 15 corresponds with y. So I'm just going to match up 9 over 6 equals x over 8, and then I'm going to say 6 over 4 equals 15 over y. Okay, now let's cross multiply. 9 times 8 is 72. 6 times x is 6x. Divide both sides by 6, and 12 equals x. Over here, 4 times 15 is 60. 60 equals 6y. Divide both sides by 6, and 10 equals y. Okay, so not too bad. Set up your proportionality statement and then solve for x and y. The one thing you want to avoid, let me say this, the one thing you want to avoid is something like this. X over 8 equals 15 over y, because that's two unknowns. And whenever you have two unknowns in one proportion like that, it is going to be pretty difficult to solve. Okay, so keep that in mind. And moving on to 21. Let's see, there was an artist, he created the mural Chicago Federation of Labor by enlarging the 56-inch by 21-inch sketch shown below. Excuse me for yawning. He used a scale factor of about 3.5. Okay, 300 or 3.5. So here we go. I'm just going to draw a little rectangle here. Here we go, and there's the old mural. It was 56 by 21. Now it says he used a scale factor. Watch this, please. He used a scale factor of 3.5 to get out, well, we'll go down like this, to get out a bigger mural, okay, like this. And so what they're asking for is what are the dimensions of the mural in inches and in feet also. Now notice this is 56 inches. This is 21 inches. Everybody see that? Now if this is your scale factor, all that simply means, this is pretty simple, but all that it means is you should take 56 times 3.5 using a calculator. And if you do that, you'll get 196 inches. And then take 21 times 3.5. And what you will get is 73.5 inches. So they did ask us to find the dimensions. I need to get rid of that, it's in the wrong place. Sorry about that. 73.5. Now, they have asked us to find the dimensions. We've done that. It's in inches. And now they want us to find it in feet. And that shouldn't be too hard. 196 inches. If you want to, let me ask you a question. If you have 12 inches, how many feet do you have? 1. If you have 24 inches, how many feet do you have? 2. If you have 36 inches, how many feet do you have? 3. Okay? So with that in mind, that simply shows me that every 12 inches is 1 foot. So if I have 196 inches, now think about this. If I have 196 inches, I'm going to take that and divide it by 12, and I'm going to get 1, 12, 76. What would that be? That would be 8, 7, 6. That would be 16 and 4 inches left over. So 16 feet and 4 inches left over. Now we'll do the same thing down here. We're going to take 73.5 and we're going to divide it by 12. All right. So 12 times 6 is 72. That's a 15, so we have 3 inches left over with. So 61 feet, or excuse me, 6. Did I make a mistake here? Well, I hope not, guys. I'm sorry if I did. I'm sorry about that. Let me divide this out again real quick. I hate that when I make mistakes, and I apologize to you guys. Okay, this is 73.5, and we're going to divide that by 12, so we get 0.15. That'd be 0.4, and that would be, let's see, 3. And what you would end up with would be 6.125. 6.125. Now they want that, of course, to be in feet and inches. So you could leave it, to be honest with you. I don't mind 6.125 feet. That's totally acceptable because they said to write your answer in feet. If you want in inches, of course, then it would just be 125 over 1,000 would be your fraction. You could go from there, but 6.125 feet is definitely fine. Okay, so there we go. Now, what did they want you to learn from all of this? I really didn't care for all the inches and feet thing. That's a little confusing, but the main thing they wanted you to learn is when you have a figure like we did right here, and you're told what the scale factor is, you can take these sides and multiply it by the scale factor, and that will give you out the similar figure. All right, number 22. And actually 22 through 26 all have the same directions. Use the diagram below to answer the following questions. So find the measure. 22 says find the measure of angle N right here. Well, here's what I should have cut and pasted this. I did not. It says in the directions F, G, H, J is similar to K, L, M, N. Now they're asking you to find the measure of angle N. Now look over here. Here's N at the end. So what angle does N correspond with? J. N corresponds with J. Remember, whenever two figures are similar, their angles are congruent. So here's J. J is a 90-degree angle, and J corresponds with N. So what that would mean then is the measure of angle N has to be 90 degrees. Has to be. Because angle N corresponds with angle J, and J is 90 degrees. So N has to be 90 degrees. Now hold on, Mr. Earhart. You didn't say these two triangles were congruent. You said they're similar. True. But don't forget that, or not triangles, but figures, excuse me. True. But similar polygons, similar figures, always have congruent angles. Remember that. Similar figures have congruent angles and proportional sides. All right. Number 23, find the measure of angle F. All right. Let's do a little grabbing and dragging here, if that'll work for us. And here we go. All right. Find the measure of angle F. Well, here's F right here. And what angle corresponds with F? K. So F and K correspond. So if K is 80, then F also has to be 80. Okay, so the answer to the measure of angle F is 80 degrees. All right, let's continue on and take a look at number 24. Number 24. Find the value of x. Now let's be really, really careful here, okay? Let's make sure we match up corresponding sides with corresponding sides, okay? It is true that 10 would go over y, and it is true that x would go over 9, and it is true that 12 would go over 18. Now I know we don't know the length of this side, and I know that we don't know the length of this side, and I really don't care. That's okay, because they didn't ask me to find that side. They asked me to find the length of x and y. So here we go. I'm going to take 10 over y, and I'm going to match it up with 12 over 18. 12 times y is 12y, 10 times 18 is 180, and y 12 would go into 180 15 times. All right, so there's the value of y. Now let's take a look at, actually they only asked us to find the value of x, didn't they? So I apologize for wasting a little time there, but that's okay. Let's go ahead and find the value of x. x over 9 equals 12 over 18. So we're going to go ahead and cross multiply. 9 times 12 is 108. And 18 times x is 18x. All right. Now, how many times does 18 go into 108? Well, the answer is 6 times. So 6 equals x. Now, by the way, I didn't mean to do this, but notice how I said earlier I wasted time solving for y. And I apologize for doing that, but I really don't think I wasted any time, because if you look at question number 25, question number 25 says find the value of y. Okay, and we just did that back here in 24, so I'm going to skip 25. But here's the answer to 24, right here, the value of x, and here's the answer over here to number 25, the answer is 15. Okay, and continuing on, number 26, find the ratio of the perimeter of one to the other. Now, let me teach you something, okay? Can I show you something, please? Look, the ratio of the perimeter from this polygon to this polygon, there's a shortcut, and I want to show that to you right now, and it's really, really, really cool. Okay, now watch this. Look, it says find the ratio of the perimeter from this polygon to this polygon. Now watch carefully. I can actually, since it says from KLMN to this one, I'm going to start first with KLMN, and I'm going to take side 18 and put it over side 12. And when I do that, I get 18 over 12. And when I reduce that, I get 3 over 2. This is so cool. Did you know, this is so neat, did you know that when two polygons are similar, the ratio of two sides is the same thing as the ratio of the perimeter? So I just saved you time. Could you have found this missing side here? Yes, you could have. And then once you found that missing side, could have you not added up all 4 sides? Yes. And you could have added up all 4 sides over here after you found this missing side. And then you would have put the perimeter of this figure over the perimeter of this figure, and you would have reduced. And guess what you would have got? 3 halves, the exact same thing. So this is a really cool shortcut that I'm showing you, and please listen and watch this carefully, okay? The ratio of the perimeters of 2 congruent figures is equal to the ratio of 2 sides. So 18 over 12 reduces to 3 halves. This 3 halves would also be the ratio of the perimeters of these 2 sides. So that's pretty cool, and that's pretty helpful to know. All right, number 27, let me grab a quick drink of water. And here we go. Triangle QRS is similar to XYZ. Now listen to this. Watch this carefully. The ratio of one side of this triangle corresponding to this side of the triangle is 6 to 7. So what's the ratio of one side of the triangle to another side? 6/7. Right? That's what it says right here. Look, the ratio of one side of this triangle corresponding to a side of this triangle is 6 to 7, or 6/7. So what's the ratio of the perimeter of these 2 triangles? What did I just teach you back here? I just taught you back here that whenever you find the ratio of 2 sides of 2 similar figures, that's going to be the exact same thing as the ratio of the perimeter. So what is the ratio of these 2 sides? 6 to 7. So what's the ratio of the perimeter? 6 to 7, the exact same thing. They're identical. Okay? And then number 28, this triangle here is similar to this triangle. The ratio of this side to this side is 5 to 2. The perimeter of STU is 35. Find the perimeter of JKL. Now, I think it'd be very wise to get a picture of these triangles. So I'm going to quickly draw JKL, and then I'm going to quickly draw STU. I don't care if they're drawn to scale, that's not a big deal to me. Now, the ratio of ST, this side right here, put a little squiggly mark on it. The ratio of ST to JK is 5 to 2. That basically means you could say this side is 5 and this side is 2 if you wanted to, something like that, okay? Now, so the ratio of this side to this side is what? 5 to 2. Now, the perimeter of STU, that means if you take this side here, and this side here, and this side here, and add them all up, you're going to get what? 35. Okay? So, think about this. I know that the ratio of the perimeter, the ratios of the two perimeters, is equal to the ratio of these two sides right here. So I can definitely say 5 over 2 equals, now what's the perimeter of STU? 35 over, what's the perimeter of this triangle? That's what I don't know. That's what I'm trying to solve. The perimeter for this triangle is 35. And the perimeter for this triangle over here is x. And so that's what I'm trying to find. So do you see, students, as soon as you know the ratio of two sides of similar polygons, you then also know the ratio of the perimeter. So now I can quickly find x, cross multiply. 2 times 35 is 70, 5 times x is 5x, divide both sides by 5, and you will get 14. So there, you just found the perimeter of this triangle. Without even knowing all three sides, you just found the perimeter of this triangle. If the ratio of this side to this side is 5 to 2, and if the perimeter of this triangle is 35, then this here, the perimeter of this triangle is 14. So there's the answer. These have been pretty tough, and I warned you guys they would be. But don't get discouraged. Keep working, okay? Nothing wrong with that. Nothing wrong with having good, challenging problems. And I feel like my tests are always reasonable. And so hang in there, work hard. Don't forget that you owe me a copying assignment too. You need to copy scale factor and similar polygons 3 times each, those definitions. So don't forget to do that. And this homework is due tomorrow. Call or email if you have any questions.